everyone, it's Lauren from UT Austin. Today we're going to learn about research. Research is the process of learning more about a topic by asking a specific question and then collecting data to test different possible answers. In doing this, we are able to further our knowledge of the world around us. Now let's take a second to learn about why we do research. Why is it important? Pause this video and take a second to talk to someone next to you and discuss some possible reasons why research is important. Then spend a minute discussing it as a group. Now that you've had the chance to brainstorm, let's go over a few key reasons why research is important. Research is important for a number of reasons. It not only helps us better understand the world around us and make important breakthroughs, such as developing life-saving medical treatments. For students, research helps us better understand abstract scientific topics by allowing us to engage with them and understand their real-world application. Now that we know what research is, we must talk about how we are able to do it. After all, it can be pretty pricey. Scientific research is often a big task and therefore requires funding to pay scientists and purchase equipment. Funding for research typically comes from 4 places: nonprofit foundations, colleges and universities, private companies, and the government. Nonprofit organizations fund research to further their cause. For example, a foundation focused on childhood cancer might provide grants or money to scientists working to develop new cancer treatment. Colleges and universities fund research to help students experience what they're learning in the classroom in a real-world setting. Research is also conducted to help improve the overall quality of education provided by a university and to gain recognition. Research also helps to prepare students for life after graduation. Private companies fund research that involves the products they create. For example, a cosmetic company might research new pigments to improve their eyeshadow formula. Finally, government organizations fund research that helps accomplish their goals. For example, the EPA provides research grants to scientists studying the environment. These scientists help the EPA protect the environment by providing them with more information about problems that need to be addressed and ways of fixing them. Now that we have a basic understanding of research and funding, let's learn about the steps we followed in order to conduct it. Step 1. First, we pick a topic we're interested in. For example, I'm interested in environmental science. Step 2. Then we research our topic of interest and pick a specific part of it to focus on. After researching environmental science, I've decided I want to learn more about urban ecosystems. Step 3. Then we formulate a specific question. I want to know about how water quality varies in Austin. Step 4. Then we create a list of all possible answers to our question. Some possible answers for my example are that the water quality is more or less the same, that it is better in formal green spaces than in informal ones, or that North Downtown has better water quality than the southern part. Step 5. Next, we gather information as needed about ways to collect data to answer a question. Then we create a set of procedures that can be used to collect data to analyze. This test should be designed to disprove answers in order to figure out which one is correct. I might decide to collect water at 5 different sites around Austin at different times and test for 3 common pollutants and their levels. Step 6. Then you analyze your data. I might create a graph for each site to identify what locations had higher levels of each pollutant. Step 7. Now you draw a conclusion from your data analysis. After analyzing my data, I found that all informal green spaces had higher levels of nitrogen than formal ones, and that phosphate levels were typically lower in North Austin. Step 8. Finally, you publish your findings and share them with your community. After analyzing my data, I write a research paper outlining my findings. Then I share it with the public by publishing it in a scientific journal, presenting at a local conference about water quality analysis, and talk to Austin's Watershed Protection Department about areas of Austin that have higher levels of pollutants and need more attention. Now that I went through an overview of research, I'd like to highlight 2 important parts of how we conduct research that are key parts of strong inference, a specific method of approaching and conducting research. The first key idea is that of having multiple hypotheses, which just means considering all possible answers to a question. Unlike in the scientific model we are taught in middle and high school that asks us to determine one hypothesis, choosing to consider multiple hypotheses when conducting research challenges researchers to consider all possible answers to their question of interest before beginning research. This helps scientists remain open-minded and prevents them from creating a test that may be designed unintentionally to support only their hypothesis and not other possible ones. This challenges scientists to explore other answers to the question they otherwise might not have explored. The second concept is the use of disproval when testing hypotheses. The reason we design tests to disprove possible answers rather than ones that prove answers correct is because sometimes we don't have technology that is advanced enough to provide a clear yes. Instead, we can use disproval to figure out what possible answers are definitely incorrect. We then accept whatever answer out of all the possible hypotheses was not disproven as the best answer to our question. It is important to remember with this that later on when technology advances, it is not uncommon for scientists to revise their findings or introduce new explanations as new evidence is presented. Science is all about remaining open to new information and adjusting our understanding of the world based on it. Before we sum things up, I'd like to share an example to help tie all these ideas together. One common example we use when explaining research is our understanding of the structure of atoms. For a long time, we used the Rutherford atom model, which looks like this. At the time, we were unable to disprove this model, therefore it was widely accepted. As time went by, we developed new technology and were able to disprove the Rutherford model. We then developed the Bohr model, which we often see in classrooms today. With even more technological advancements, we developed the quantum mechanic model, which is one way we look at atoms today in more advanced chemistry classes. Over time, the use of disproval allowed us to study atoms and their structure. Although we didn't always have the technology we have today, scientists were able to meet themselves where they were at and make progress towards a better answer. This showcases the beauty of this approach. It allows us to keep challenging our ideas and move forward while also making progress where we are at. This also showcases the idea of having multiple hypotheses. New technology allowed us to explore new hypotheses and test them, which led us to develop more accurate models, advancing science. To sum things up, science is all about being open to new ideas and challenging old ones. By using concepts like multiple hypotheses and disproval, we are able to remain open-minded and conduct research to continue learning about the world around us. It is thanks to research and technological advancements that we are able to solve problems, elevate students' education experience, and better understand our world. Thanks for watching!